So our new subject today is about properties of numbers. What does it mean by properties of numbers? It's defined simply as the grouping or arrangement of numbers in numerical or algebraic expressions. But then we're covering this properties of numbers. We're dealing with numbers, and eventually we'll be dealing with variables in algebraic expressions as well. But before we go on, I would like to introduce myself. My name is Ming. I have a degree in civil engineering and passed the board in 1990. Now I found myself fascinated and enjoying teaching algebra. Now let's go back to our topic. Properties of numbers, there are five of them. First one is the commutative property of addition. Second one is the commutative property of multiplication. The third one, the associative property of addition. The fourth one, the associative property of multiplication. And lastly, but not the least, the distributive property of multiplication over addition. So let's go to the first property. Property number one. It says here the commutative property of addition. That means the placement of numbers in a numerical expression. Say the arrangement. We're talking about here the word from the word commutative, from the root word commute. What do you do if you commute? It's you go from place to another place, right? So it's presenting a variable. Let's say a plus b. Let's say variable a plus variable b. If you notice, a is on the left, b is on the right. From the word commutative, that means if you move them, it will be the same, right? So what does it mean by that? So like if it's a plus b equals b plus a, it's the same way. So that should be equal to the same way. In algebraic expression, let's say we have x plus y is the same as y plus x. How do we represent that in numbers, in numerical expression? So let's say 2 plus 3 is the same as 3 plus 2. It's very simple, right? And this applies to multiple term variables or multiple term numerical expression like this one right here. So 2 plus 3 plus 4 plus 5 is the same way, however you arrange them, as written next to one another or whatever, like different arrangement like this. Whichever place you move is the same as 3 plus 4 plus 2 plus 5. So that's how it is. Now let's go to property number 2, the commutative property of multiplication. Okay, the commutative property, this is the same thing again from the word commute. And now how is that applied in multiplication? So it is the placement of numbers or variables again. Since we're talking about numbers over here, so let's give an example for that one. Let's say in math talk, presenting variables. So variable a times variable b, variable a, variable b, We say commutative property, commute, from the word commute again. If you exchange the places of both of them, A times B is the same as B times A. Or you can simply write that AB is the same as BA. Same thing. Sometimes you put a dot over here. It's the same thing as without a dot. AB is equals to B times A. Okay. So in algebraic expression, you can say over here x times y is equals to y times x. Putting a bracket or parentheses on there is really unnecessary. So you can do it also, but normally it's written as x and y without the parentheses. Okay. And how about if we do it on numbers? Okay. So let's say that is 2 times 3 equals the same as 3 times 2. It's commutative. So that means they commute, they move places. So now 2 times 3, you see, this is exactly the same as 3 times 2. Now it's written differently. You can have that 2.3, 2 times 3 is the same thing. It's just a different way how to express them, how we write them. It's the same thing as 3.2 or, okay, yes, symbolize multiplication. And so the same thing, if we get another example over here. Right? 2 squared times 3 cubed is the same as 3 cubed times 2 squared. Or we can do it in parentheses. 2 squared times 2 times parentheses 3 cubed is the same as 3 cubed times 2 squared. Alright. Now let's go to the third properties of numbers. So here the associative property of addition. Now from the word associative, the word again is from the word associate. How do you associate? Well, if you are an associate, that means you go close together, right? Or you have at least there's a close relationship. So, all right, when it comes to properties of numbers and associative property of addition, it states that when you add 3 numbers together, no matter how you group them, the answer still would be the same. So in math talk, representing variable expressions or algebraic expressions, we have this, let's see, variable A plus variable B plus variable C. So that's ABC. It says here associative. That means you get close together. Let's say we enclose that in parentheses. It's A and B. They're close together, so they're grouped as one group, separated from C. So it would be the same. The answer would be the same, or it cannot be influenced by how these variables are enclosed or grouped together. So let's say A plus B grouped with the parentheses as one, and then this is considered like one term, then separate from another term C. So it's the same, is exactly the same as A plus B plus C, but if you notice the grouping first it was grouped right here, and now the grouping will be now over here. So it would be, the answer would still be the same. So in another example, if we go to, like, say, variables, I mean algebraic expressions, let's say x plus y plus z, that's z. If you group this one right here together, it will be equal or the same as x plus y plus z. You group this one at the same time, either way the answer would still be the same. And how about when it comes to numbers? If we go, alright, if we go to numbers, let's say 2 plus 3 plus 4 is equal to the same as 2 plus 3 plus 4, right? If we solve that, it should be the same, right? So that's how it is. Or let's say we solve this. 2 plus 3 is 5 plus 4. Because how about this? 2 in 2 plus, we group this together, like, do you remember PEMDAS? Oh, please excuse my dear aunt or Aunt Sally. How, yeah, you pronounce that? So it's the same. So it's like 3 and 4 grouped together. You can do that one first. 3 plus 4 is 7. So 3 plus 4 is 7. So 5 plus 4 is 9. 2 plus 7 is 9. So that's how it is. It's the same thing. Now let's go to property number 4. Properties of numbers. It says here the associative property of multiplication. How is that expressed or represented? Here in math top, we're represented as like the same way as the associative property of addition, to say, from the word associative, associate again, but this time it's multiplication. So how do we write it down? Okay, so if we have variables a times b times c times c, well, the grouping right here is, if we say close it in parentheses, a times b times c is the same as a times b times c. Is the same thing. Or you can just remove the dot right there. It would be the same way. So a b times c equals a times b c, or the same way, or it's the same thing as a times b times c is equals a b c. The same thing, right? So when it comes to algebraic expression, as I said, so say x, y, z is the same as zxy. Right? How about if we solve numbers? Okay, if we do it in numbers, we have 2 times 3 times 4. If you enclose that in parentheses, we have that is equal to, so 2 times 3 times 4. Alright, can we solve that? let's say 2 times 3. The answer should be equal to the same on the right side. 2 times 3, 6. So that's 6 times 4. And here, we do that in the parentheses first. 2 times 3. 3 times 4. That's 12. Is that equal to the same? 6 times 4 is 24. 2 times 12 is 24. So it's correct. Okay. So let's go to the fifth property of numbers. Now it states like this: the distributive property of multiplication over addition. Now this time is somewhat different from the previous 4 properties, because we have a word here, distributive, from the word right here, distribute, and it says here multiplication over addition. So how does that work? So it says it's stated like this, that when you multiply a monomial expression, let's say 2 times a binomial expression, such as parenthesis x plus 3, let's say let's just say it, just write it down on the board. Let me see. Let's just say 2 times, let's say x plus 3. Okay, it says here distributive. It means distribute, from the word distribute, and it's here if it's 2 is a monomial. It's one term. It says it's a monomial, whatever it is, but we say just simply 2 multiplied by a binomial. This is considered binomial, if you remember that. 2 terms. Okay, it's a 2-term algebraic expression. Let's say, so 2 times the quantity x plus 3. The distributive property is like this. You distribute it. So at first, since this is multiplication, and so 2 multiplied to x, that's the first one, and then the next one is 2 multiplied by 3. So in doing that, so 2, that's 2x, 2 times x, plus 2 times 3 is 6. That's how it works on that. The distributive property of multiplication over addition, the plus sign right there, addition. So let's say in math talk, we say, as an example over here, it's a times b plus c is the same as, we do that again. So this a multiplied to b, and then a multiply that with the c. So the answer would be a times b. Since the bracket stands for a multiplication, so that a times b is ab, and then a times c, carry over the plus sign, a plus b, a times c is ac. Is it simple? And now before we conclude our topic on properties of numbers, I just have 2 notes over here. So with regard to the properties of numbers, say subtraction, we touched addition, but we didn't mention anything about subtraction, like commutative property of subtraction. Is there such a thing? Well, it won't apply on subtraction. Let's say commutative for subtraction. Let's say from the word commute again, right? So let's say 2 minus 3. Okay, let's do it like this. So we have here for subtraction, commutative. Is that a commutative property? Is there such thing as commutative property of subtraction? Now let's find out. So 2 minus 3, is that the same as 3 minus 2? Is that the same? It is not. This is because 2 minus 3 is negative 1 and 3 minus 2 is 1, right? Let's say another one. 4 minus 1, is that equal to 1 minus 4? Is that, let's say 4 minus 1 is 3. Is that equal to 1 minus 4? 1 minus 4 is what? It's negative 3. So it's not applicable on subtraction. Okay, that's one of them. And how about on in division? So let's say that's subtraction. It's subtraction. How about in division? Do you think it's applicable? Division. All right, let's do that. Commutative property. Let's say 2/3. Okay, is that equal to 3/2? That's not. It is not. So that's not. It's not equal to 3/2. And another one is how about 1/4? Say 1/4. Is that equal to 4/1? It's not. It's not equal. So that simply means it's not applicable on division as well. Thanks for watching, guys, and I hope that I helped you in any way in enhancing your knowledge in this lesson. Let me subscribe by clicking the button below. Have a great day.